Hello and welcome back to the lecture of time series econometrics. In the past two lectures, we have seen something very interesting. We can actually convert a AR series into a MA series and a MA series into a AR series. So let me write it down. So first we have seen that we can actually convert a AR1 series. A AR1 series is basically same as a MA series of infinite order. AR1 series is equal to MA series of infinite order. Whereas in the second case, we have seen that we can have a MA1 series. We can take a MA1 series and convert it into a AR series of infinite order. MA1 series, convert it into a AR series of infinite order, right? So now that is very interesting. Why really we do convert, that's the first part, and second, how really do we make sense of it? So let me write down the questions. Let me write down the two things we want to understand. Why do we need to do this? Why do we do this? Why do we do this? Double do. And then the second part is, how do I explain it? How do I explain a conversion of a series of order 1 into a series of order infinite in both the cases? How do I explain it? Let me write down. How do I explain it? How do I explain it? How do I explain it? Explain it. So let us try to answer both the questions. So before that, let us write down the equations that we got when we converted a AR series into a MA series and a MA series into a AR series. So let me write down the first case, okay? In the first case, what we got was our YT in our AR series is nothing but equal to ET or epsilon T plus phi epsilon T minus 1 plus phi square epsilon T minus 2 phi cube epsilon T minus 3 and so on, right? Which is basically, if I compare it to the AR1 series, is basically YT minus, so phi YT minus 1 plus epsilon T, okay? This is basically that. So that's basically my AR1 series, and so this is my YT, this is my AR1 series, and this is my the upper one is basically MA infinity series, okay? So they are basically same. Whereas in the second case, I wrote YT is equal to minus of theta YT minus 1 minus of theta square YT minus 2 minus of theta cube YT minus 3 and so on, and then I have the innovation term or the error term, which is epsilon T. So I am interchangeably using E and epsilon, so that's just basically the same thing, epsilon T, okay? So then that's my that's basically, okay, so and other equation I get when I use a MA series is basically ET or epsilon T minus theta ET minus 1. So this is the last one is my MA1 series, whereas the one above is my AR infinity series. AR infinity series. Now the question is, why do we do this? And both the process is known as invertibility. So basically you invert from one series to the other series. Now question is, why do I do that? Now frankly speaking, for the first case, when I actually invert the y to the error terms, it really doesn't have a lot of practical implication. But whereas for the second case, when I invert MA1 into AR infinity, that has a lot of implications, and it has to do with the error innovation term. So the thing about the error term is we really cannot measure the error term, right? I mean, you really do not know what was the error term for the past period. So what you want is rather is that the yt value or yt minus 1 value, because that is something you can observe. So when I convert a MA1 series, that is the case 2, into a AR infinity series, what I'm doing here is I'm actually removing the error term, replacing the error term with the corresponding yt, yth term or y term of different period, right? And so which I can actually measure. That is really very helpful. So the second part is really very helpful. The first part is not, because first part is more likely to show the symmetry that I can actually convert a AR1 series also to a MA infinity series, right? And in both the cases, we have seen, I should again write it down, that in both the cases, these two conditions are needed to be fulfilled. Otherwise, you cannot really do it. So that is modulus of phi less than 1 and modulus of theta should be less than 1, right? So these two conditions have to be fulfilled. That's great. So far so good. Now that part, what we have discussed answers our first question. Why do we need to do this? Because we cannot measure the error terms, so we rather have the yt terms replacing the error terms, whereas I am actually constructing the series. Okay. Now, how do I explain it? That's a very important question. Suppose in the second case where I'm using a MA1 to, when I'm converting MA1 into AR infinity, in that case, what I am using is yt in terms of yt minus 1, yt minus 2, yt minus 3. Now, we have seen in case of MA series that it is, you can have the value for its correlation coefficient only up to lag 1, right? So why something that happened in lag 2, lag 3 period is actually important here. Okay, so to understand that, I have to use I have to actually show you how these different terms are coming. So let me write down again the MA series where I write yt for different periods. So yt equal to, what do I write? Yt equal to I have et minus theta et minus 1, right? Now if I write yt minus 1, I will write et minus 1 minus theta et minus 2. Or if I write yt minus 2, then I'll write et minus 2 minus theta et minus 3. Okay, so this is how I will write my different equations in my MA series. Now let us try to understand it. So when I'm writing the first equation, when I'm writing et minus 1, so et minus 1, let me use a different color. So et minus 1 is actually getting determined, the past period error is getting determined by something called yt minus 1 and et minus 2, right? So then when I actually use et minus 1, I'm actually in effect using yt minus 1 and et minus 2. Similarly, when I use et minus 2 is actually getting determined by yt minus 2 and et minus 3. Okay, so that way it is actually, we're actually taking into account this sort of infinite series where I am actually taking care of all these yt terms. Okay, all these yt terms, but given the fact that my theta values are actually less than 1, and as I keep on increasing my theta, basically increase the power, so it becomes almost negligible and becomes 0. So, okay, so that is how we can explain how the MA1 series is converting to a AR infinity series. On the same vein, if I basically think on the other way around, when I use a AR series, and that we have already done previously, and I'll just briefly show you that, is that when I use something like this, you are already familiar with yt equal to phi yt minus 1 plus epsilon t, and you can actually do like, or you can write yt minus 1 is equal to phi yt minus 2 plus epsilon t minus 1. So basically what is happening is, or let me write another, yt minus 2 phi equal to phi yt minus 3 plus epsilon 2 plus epsilon 2 plus epsilon 2. So what is happening is, your yt minus 1 here, this yt minus 1 here, is that value is getting determined by et minus 1, right? So you have a et minus 1 component. And again, when I take, say, this et minus 1 and yt minus 2, right? And when I take yt minus 2, it is again getting determined by et minus 2 and yt minus 3. And yt minus 3 in effect will be getting determined by et minus 3. So basically, in a way, when I have a AR1 series, that basically incorporates all the error terms in a infinite series. And that is why you have a MA series. That is how we can actually express a AR1 series into a MA series of infinite error, because you are actually taking care of all the error terms in infinite at infinity, right? So that's how we can basically explain how we can expand this to series. Finally, as I said, that it is more important for the MA series to convert into AR series. So you will see in general in textbook, when they talk about invertibility, they actually use MA series to, MA1 series to and convert it into AR infinity series. But that in the concept of invertibility is actually is applicable for inverting both the series. All right. So that's it for this lecture.